Okay, so the first one here, we have to have a common denominator. For the 6 and the 8, that's going to be what? 24. Very good. So 5/8 becomes how many 24ths? 15. Good. 5/6 becomes 20 24ths. Excuse me. We add 15 24ths and 20 24ths. Is 35 24ths. That's improper. We can get 1 out of it with how many left over? 11 24ths. So we keep the 11 24ths, carry the 1. 1, 8, and 9 is 18. Keep the 8, carry the 1. 1, 2, and 3 is 6. So 68 and 11 24ths. How many of you had that one? Good. Did you do it by hand or calculator? Or both? Calculator. Okay. Do you have a scientific calculator or are you still using the cell phone calculator? Okay. They do have apps for the phone that do fractions. I hesitate to give out because like I mentioned, students will show me one that's free that works, and then a year later, now they're starting to charge for it. So I kind of gave up on keeping up on which ones were free. But I know there's like a math calc was the one that was last year that did fractions. So here, subtracting, we still need common denominator. For 4 and 5, it's going to be 20. Very good. So 1/4 becomes how many 20ths? 5. 4/5 becomes 16. 5 and 16 become 21 20ths, which is 1 and 1/20. So we keep the 1/20, carry the 1. Oops, what did I do wrong there? We're not adding, we're subtracting. 5 minus 16 is not possible, so we have to borrow. This becomes 1, and this becomes... Remember, we have to add whatever the denominator is. So it'll be 25 20ths. 25 minus 16 is 9 20ths. We have to borrow here to make that 11 and this 6. 11 minus 18, or 11 minus 8 is 3, and 6 minus 3 is 3. So 33 and 9 20ths. Now for 3 and 4, multiplying and dividing, we do not need common denominators. But remember, the long multiplication and division processes are pretty complex. So to avoid that, we do what? Make them improper fractions. So 4 1/2 becomes 4 times 2 is 8 plus 1 is 9 halves. Remember, the denominator doesn't change when we do the conversion between improper and mixed number. 2 2/3 becomes 8/3. Now we can cross cancel. 9 and 3 can both be divided by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. 2 and 8 can both be divided by 2. 2 divided by 2 is 1. 8 divided by 2, 4. 3 times 4 is 12. 1 times 1 is 1. 12 over 1 or just 12. I had a group a few years ago that just fascinated them. They could multiply 2 fractions and get a whole number. 5 3/8 divided by 1 3/4. Well, just like with multiplication, we're going to turn them into improper fractions. 5 3/8 becomes 43/8. Very good. 1 3/4. 7/4. Now this is still division. We do have to turn it into multiplication. Remember, the first fraction never changes. The operation always operates on the number that comes after it. So we turn that into times 4 over 7. Now we can cross cancel 8 and 4, both divide by 4. 4 divided by 4 is 1, and 8 divided by 4 is 2. So 43 times 1 is 43. 2 times 7 is 14. If I divide that out, 14 goes into 43 3 times. That would be 42 with 1 left over. So that is 3 and 1/14. Any questions? Okay. Well, another thing we went over last week that I want to make sure we have down are things like this. Things like that, and like this one. Give those two a try quick and we'll talk. So the first one up here. Start in the parentheses. If we subtract 3 and 1/6 minus 2 and 5/6, what do we get? 2/6 or 1/3, right? So we can take out the parentheses. Now we have the multiplication to do here. 1 1/2 times 1/3. 1 1/2 becomes 3 over 2 times 1/3. 3's cross cancel, give me 1 and 1, that's 1/2. So that becomes 1/2 there. So now we've got 2 and 1/3 plus 1/2, which is 2 and 5/6. 2 and 5/6 plus 2 and 3/4 is 5 and, oh, what is that? 10 and 9, 19, 7/12. So 5 and 7/12. Any questions on that one? It is long, yeah. I mean, the calculator definitely helps. It's just the order of operations. It's just, you'll notice I wrote this one off to the side, and I do that a lot. Write them off to the side and do the calculations and put them back. Because if you try to do all the calculations right within here, it gets really cluttered. Now, like this, I probably should have wrote that out as 2 and 1/3 plus 1/2 and did the common denominators. Number 6. So we're going to start by doing the top of that. 2 and 1/2 times 1 and 3/5. 2 and 1/2 is 5/2. 1 and 3/5 is 8/5. The 5's cross cancel out. The 2 and 8 both divide by 2 to give me 1 and 4. So that's just 4 on top. On bottom, I have 1 2/3 plus 2 1/6. Common denominator is going to be 6. So 1 2/3 is 1 4/6 plus 2 1/6. That'll be 5 6 3 and 5 6. So that becomes 4 divided by 3 and 5 6. So now how do we do that whole number divided by a fraction? Well, first we have to make the 4 over 1. We have to make the 3 and 5 6 become 23 6. 3 times 6 is 18 plus 5 is 23. Then 4 over 1 doesn't change. We turn this into 6 over 23. 4 times 6 is 24. 1 times 23 is 23. So that's 1 and 1/23. So now we saw there we had a whole number divided by a fraction. What happens if we have whole numbers in other operations? Let's say we have 3 and 1/8 divided by 5, or 2 and 3/4 times 6, or 5 plus 3 1/8, or 7 minus 2 and 1/3, or 8 and 5/6 minus 3, or 7 and 1/2 plus 2. Give those a shot. We'll talk about them in a minute. So let's see how we're doing here. The first one, 3 and 1/8 divided by 1/5. I'm going to make that, of course, divided by 5 over 1. 3 and 1/8 is going to become 3 times 8 is 24 plus 1 is 25/8. And I'm going to do the reciprocal here, so that's going to be times 1 over 5. The 25 and the 5 both divide by 5 to give me 1 and 5. 5 times 1 is 5. 8 times 1 is 8, so I get 5/8. Any questions on that one? All right, number 2. I make that 6 over 1. 2 times 4 is 8 plus 3 is 11/4 times 6 over 1. Well, 11 times 6 is 66. Actually, before I do that, let's do some cross canceling. And divide the 4 and 6 by 2 to give me 2 and 3. So 11 times 3 is 33. 2 times 1 is 2, which reduces to 16 1/2. Any questions on that one? Anybody have both of them right so far? That's just reducing is all. So same thing. So 5 plus 3 1/8. Well, the nice thing here is we always have common denominators. We just put in 0/8. 0 plus 1 is still 1/8. 5 plus 3 is 8. Now here you might ask, why did I just do the 5 plus 3 is 8 and just keep the 1/8? That's fine, but when we go to subtract, we have to have that idea of 0/8 or 0 whatever over the denominator. Because over here, like the 7 and 1/3, or 7 minus the 2 and 1/3, we have to be able to put in 0/3 there. So that we can borrow and make this 6. Adding 3 makes that 3/3. So 3 minus 1 is 2/3. 6 minus 2 is 4. 4 and 2/3. Now the fraction minus the whole number is quite a bit easier. 8 and 5/6 minus 3. If I wanted to, I could put in 0/6 here. 5/6 minus 0/6 is still 5/6. 8 minus 3 is 5. So 5 and 5/6. Over here, we got 7 and 1/2 plus 2. Again, we could put in 0/2. 1/2 plus 0/2 is 1/2, and 7 plus 2 is 9. Any questions there so far? So now that we can do operations with these fractions, we can step up to using these fractions in cases where we would normally do operations with them, like this. This is a simple equation. It's just it looks ugly because there's fractions in it. But this is really no different than something like 2x minus 7 equals 11. The steps are exactly the same. Over here, what would I do to solve it? I'd add 7 and then divide by 2, right? Same type of thing happens over here. My first step is going to be to add the 5 1/4. So 3/8 x equals, that adds up to 11 3/4. Then what? Divide by the 3/8. So x equals, we have to do 11 3/4 divided by 3/8. 11 times 4 is 44, plus 3 is 47/4, times 8 over 3. 4 and 8 cross cancel to give me 2 and 1. 47 times 2 is 94. 1 times 3 is 3. 94 divided by 3. 3 goes into 9 3 times. Nothing left over. Bring down the 4. 3 goes into 4 once. That's 3. There's 1 left over, so that's 31 1/3. What do you think? Not so bad? It's just, just like solving any other equation, you just have to deal with the fractions. I'm going to have you guys try a couple. Did you get what you needed off of there? Or do you want me to go back up for a minute? Okay, I'll give you just a second. Okay. So have you guys try a couple here. The first one's going to be 2/3 x plus 1 1/2 equals 3 3/4. The second one, 2 and, let's do 1/4 x minus 2 and a half equals 4 1/3. I'm going to have you try those two. So for the first one, where do we start? Subtract 1 1/2. So 2/3 x is all that's left on the left side. If we do out the math, 1 3/4 minus 1 1/2 is 2 1/2. 2 and a fourth, right? So then what? Divide by 2/3. So we're left with x on the left side. We have 2 1/4 divided by 2/3. I wrote that really bad. 2 1/4. 2 times 4 is 8, plus 1 is 9/4. That'll be times 3 over 2. You'd be really tempted there to use the 2/3 and try to cross cancel, but it's division at that point. So you cannot cross cancel until you take the reciprocal and make it multiplication. Here we could cross cancel, but nothing does. So we got 27 over 8, which is 3 3/8. How many of you had that? Do you see how we get to it? Okay. Sorry. So for number 2, where's our first step? Add the 2.5. So the 2.5 goes away. On the left, we have 2 1/4 x. On the right, we have 4 1/3 plus 2.5. That ends up being 6 5/6 if you do out the addition. Find the common denominators and add them together. Then what? Divide by the 2 1/4, 2 1/4. So all we have left on the left side is x. We have 6 5/6 divided by 2 1/4. We make the improper fractions. 6 times 6 is 36, plus 5 is 41/6. 2 times 4 is 8, plus 1 is 9/4. Again, it would be tempting to cross cancel here, but we can't yet. We have to make this 41/6 times 4 over 9. This is where we would be able to cross cancel if anything did. Unfortunately, here that does not. Oh, you're right. 6 and 4 do. 2, both divide by 2 to give me 2 and 3. Good catch. 41 times 2 is 82. 3 times 9 is 27. 27 goes into 81 3 times with 1 left over. So it's x is 3 1/27. What do you think? Fun stuff? Sure. Well, let's take a look at a problem like this. X over 7 equals 5. We can interpret this over here in one of two ways. We can interpret that as just x divided by 7 equals 5, and then just solve it by multiplying by 7. You get x equals 35. And in that type of problem where it's just one little fraction like that, that's probably the easiest way to do it. The other way to interpret it would be x over 7 is equivalent to 1/7 times x. Dividing by 7 is the same as multiplying by 1/7 equals 5. And now we could divide by 1/7. We still get x equals 35. We get the same answer either way. Depending on the rest of the problem, sometimes it'll be easier to think of it this way as 1/7 x. And sometimes it'll be easier to think of it this way as x divided by 7. The hard part is getting enough experience with them to learn which problem is easier to do which way. For example, we might have x over 3 plus x over 8 equals 22. We can think of this in one of two ways. The first way to think about it is that fractions. X over 3 is 1/3 x plus x over 8 is 1/8 x equals 22. Now, just as if we had 5x plus 3x equals 40, what would we do over here? We'd do 5 plus 3 is 8x, right? We would just combine those x's. Well, we can do the same thing over here. 1/3 plus 1/8. 1/3 plus 1/8 is 11/24. So this becomes 11/24 x equals 22. And then we would divide by the 11/24. That divides out x equals 11/24, or 22 divided by 11/24 is 48. So x equals 48. Had we chose to leave it as x over 3 plus x over 8 equals 22. About the only way we could think of that would allow us to solve it. X is divided by 3 and x is divided by 8 is to reverse both of them at the same time. How can I reverse dividing by 3 and dividing by 8? Well, I multiply by 24. But notice when I multiply, most of the time when we multiply or divide, there's only one piece on each side of the equation. The reason for that is when we multiply or divide, we have to multiply every digit of the equation. So we have to do 24 times x over 3. We also have to do the 24 times x over 8 and the 24 times 22. So 24 times x over 3, we make that 24 over 1 times x over 3. That's 24x over 3, which simplifies 24 divided by 3 is 8x. We do the 24 times x over 8. 24 over 1 times x over 8 is 24x over 8. 24x divided by 8 is just 3x. And then we do the 24 times 22, which is 528. So then we can solve that. What's our next step in solving this here? Well, first of all, we got to combine them. 8x and 3x is 11x. Is 528. And then we can divide out the 11. 528 divided by 11 is 48. We get the same answer either way. Now, in this case, I think this is simpler. If you're not totally baffled by fractions, adding 1/3 and 1/8 is simpler than doing this multiplication process over here. However, we will run into equations where doing this multiplication, where you have to multiply every step, is really about the only way to get the answer. We'll look at some of those before we're done here. The next kind of form of fractional equation might look something like this. This is a fraction, but it's kind of after the fact. Remember, when we solved equations, we asked what's been done to our variable. So here again, we ask what's been done to x. In this equation, if x were a number, the first thing that was done to it is it's multiplied by 3. Then what? The 7 was added to it. Now, this is a fraction bar, which tells us we had to do all that stuff on top first. And we've already done that. So then the next step is to divide by 4. When we go to take an equation apart, when we go to solve it, we have to take the pieces off in reverse order. We take off the last piece that was put on first. Well, the last piece put on was dividing by 4. So we're going to multiply by 4. We have to make sure we do that on the other side as well. Multiplying by 4 here just takes this piece off. That's gone. All that's left here is 3x plus 7. On the right side, we've got 7 times 4 is 28. Now from here, this looks like equations we have solved quite a bit. So to go ahead and solve this one, what's our first step? Subtract 7. So 3x equals 21. And then divide by 3. X equals 21. Just like always, in any of these, you can take that x equals 21 and put it back in for x and make sure you get the same value on either side of the equation. We're going to trust that you can do that here. We might have something like this. Tell me what to do with it first. I have to multiply the 16 to get rid of it. I have to multiply the other side by 16 as well. So on the left side, what do we have? Just the 7x minus 1. The 16's disappeared. Everything else is the same. On the right side, 3 times 16 is 48. What's next? Plus 1. So the minus 1's gone. We have 7x equals 49. And then divide by 7. X equals 7. I'm going to have you try this one in your notes. So we start out by multiplying by 2. Very good. So we have 5x plus 7 equals 22. And then subtract the 7. So 5x equals 15. And finally, divide by 5. Give us x equals 3. What if we do something like this? Well, remember we said the first thing we have to do before we can solve any equation is to make sure we simplify anything we can on either side. The parentheses here gives us something we can simplify on the left side. 5 times 3x is 15x. 5 times negative 2 is a negative 10. That's still, so all that we do is we replace this piece here with that 15x minus 10. So it's 15x minus 10 over 10 equals 5. And now it becomes that same process we were just doing. What do we do next? Times 10. So 15x minus 10 equals 50. And then careful. Add the 10 first. Very good. So 15x equals 60. And then we can divide by the 50. So x equals 4. Okay, that does take us up to 9:20. That's our break. Go ahead and take 10 minutes and we'll come back and we'll keep working. So our next step is to look at equations that look like this. This is just like the last ones we've been doing, only now instead of whole numbers, we have fractions to deal with. The process is still going to be the same. Where do we start? Multiply by 7/8. So on the left side, all it does is cancels out that 7/8. We have 2/3 x minus 1/4. So it always just leaves us with that numerator, top of the fraction. On the right side, we have to multiply out 4/5 times 7/8. We're going to be able to cross cancel the 4 and the 8, give us 2 and 1. 1 times 7 is 7, 5 times 2 is 10. So that's 7/10. What will our next step be? We'll have to add the 1/4. So adding 1/4 makes that 1/4 go away. We have to add 1/4 on the right side. So we've got 2/3 x here equals 7/10 plus 1/4. Well, we're going to make that 14/20 plus 5/20 is 19/20. What's next? Divide by the 2/3. So that 2/3 is gone. X equals 19/20 divided by 2/3 is 19/20 times 3/2. 19 times 3 is 57. 20 times 2 is 40. 40 goes into 57 once with 17/40 left over. What do you think? Not horrible? Getting easy again? So let's have you guys try one of those. So 3/4 x plus 1/3 over 1/2 equals 2 1/8. Give that one a shot. Trickier. Where do we have to start? Times the 1/2 makes the 1/2 go away. Times 1/2 over there as well. So on the left we have the 3/4 x plus 1/3. 2 1/8 times 1/2 is 1 1/16. Now then we have to subtract 1/3. So we're left with 3/4 x equals 1 1/16 minus 1/3. Gives us a common denominator of 48. We have to borrow from the 1, make that a 0. This becomes 51/48. Minus 16 is 35/48. So 3/4 x equals 35 over 48. And then we divide by the 3/4. X equals 35/48 divided by 3/4 becomes 35/48 times 4/3. We can cross cancel the 48 and the 4, both divide by 4. 4 divided by 4 is 1. 48 divided by 4 is 12. 35 times 1 is 35. 12 times 3 is 36. So x is 35/36. What do you think? So just another small step up would be to do this. I'm going to have you try that one, see what you come up with. So we start out, we have to multiply by the 2 3/8. So on the left side, we have the 1.5x plus 2 1/4 equals, well, 1 1/3 becomes 4/3. 2 3/8 becomes 19/8. We can cross cancel the 4 and 8 to get 2 and 1. So 1 times 19 is 19. 3 times 2 is 6. So it's 3 and 1/6. So now we have to subtract 2 and 1/4. So that's gone. We're left with 1 1/2 x equals, well, we got to find our common denominator here, which is going to be 12. We've got 2/12 minus 3/12 can't be done, so we borrow from the 3. That becomes a 2. This becomes 14/12. 14 minus 3 is 11/12. The 2 minus 2 is 0. So we got 1 1/2 x equals 11/12. We divide by the 1 1/2. So x equals 11/12 divided by 1 1/2 is 11/12 divided by 3/2, which is 11/12 times 2/3. 12 and 2 cancel to give me 1 6. 11 times 1 is 11. 6 times 3 is 18. That is 11/18. What do you think? Maybe not the most fun you've had in a while. Doable. We can run into equations that look like this. To solve an equation like this, we have a couple of options. Option 1. Since this is a proportion, remember a proportion is just one fraction equal to another fraction, we can cross multiply. Let's take a look at option 1. So cross multiplying requires we multiply the two diagonals. So the first diagonal is this direction, right there. That's a 5 times 4x minus 5. That has to equal the result from the other diagonal going this direction. I'll put 4 first times 2x plus 17. And now I can solve that equation. All I have to do is do the parentheses on each side. 5 times 4x is 20x. 5 times negative 5 is minus 25. That's all that we can do on the left side. So we go to the right side. 4 times 2x is 8x. 4 times 17 is 68. So now we've combined and reduced whatever we could on each side. Now we have to check to make sure that the variable is on only one side. And it's not. There's a variable on both sides. So we get rid of one by subtracting the smaller one, the 8x. Bless you. 20x minus 8x is 12x minus 25 equals 68. And then we have to add 25 to get rid of the minus 25. 12x equals 93. Our final step is to divide by 12. X equals, now both 93 and 12, by the way, can be reduced by 3. I'm going to do that before I divide them out. 93 divided by 3 is 31. 12 divided by 3 is 4. So that means that's 7 3/4. Remember, anytime we have a division problem, we can treat it as a fraction. So we could reduce that, make it easier to divide out. Let's look at another one like that. In fact, let's have you guys try one. We'll give you a few. Okay, so we're going to cross multiply here. We'll go this direction first. We've got the 4 times the 2x plus 3. Then we've got this direction here. We'll have the 7 times the 5x minus 21. Now we have to do each multiplication. 4 times 2x, 8x, and 4 times 3 is 12. Good. On the other side, we've got the 7 times 5x, 35x, and 7 times negative 21, minus 147. There you go. Now we do still have an x on each side. What are we going to do with that? Subtract the 8x, the smaller one. So we've got 12 equals 35 minus 8 is 27x minus 147. And then other way around, actually. Add the 147. Here's our equal sign, so we got to get this x alone, so we got to get rid of everything on this side. We add the 147, is 159, equals 27x. And then divide by 27. So we've got x over here. 159 divided by 27 really doesn't divide out at all. Actually, both 159 and 27 divided by 3 makes this 51 over 9. Actually, those both still divide, don't they? Did I divide that right? Should be 53 over 9. That's why. 53 over 9. So then we've got to put, I'm just all full of little errors here. 53 divided by 9 goes in there 5 times. That's 45 with 8 left over. So there's 5 and 8 ninths that we get. Do you guys have that? No? Okay. Just didn't give you enough time. Okay. That makes sense. Any questions on it? Okay. Well, that works fine as long as it's one fraction equals another fraction. We can do that cross multiplying. Option 2, let's say we got 5x minus 21 over 4. And 2x plus 3 over 7. Option 2 is to use the least common denominator. Our denominators here are 4 and 7. What's the least common denominator for 4 and 7? 28. It's going to be the smallest common denominator for both of them. So what we're going to do is we're going to multiply this whole thing by 28. We've got to be careful how we do this. So the 28, multiplying the first piece here, that's 28 over 1 times 5x minus 21 over 4. Now, we're going to treat this as though there's parentheses around the top of this. And you'll see why in just a moment. We cross cancel the 28 and the 4, both divide by 4. 4 divided by 4 is 1. 28 divided by 4 is 7. Now we have to distribute the 7. 7 times 5x is 35x. 7 times the negative 21 is negative 147. On the other side, we have the 28 over 1 times 2x plus 3 over 7. Again, we treat this as though there's parentheses up there. We cross cancel the 28 and 7, both divide by 7. 7 divided by 7 is 1. 28 divided by 7 is 4. Then we distribute the 4. 4 times 2x is 8x, and 4 times 3 is 12. This is the exact same equation we got to by cross multiplying up above. So now we would go through those same steps to solve that equation. We'd subtract the 8x, add the 147, and go from there. The reason we even throw this method out there, I think cross multiplying is way easier when it's only, one fraction equals another fraction. The reason we put this method out there is we do sometimes run into a case where it's more than one fraction. We might have something like 4x plus 3 over 15 minus 2x minus 3 over 9 equals 6x plus 4 over 12 plus x over 18. When we look at this, I'll actually change this from 12 to make it a little bit easier on us. I want to make that 6. Makes it just a touch easier. A touch. Yeah. There are 4 fractions here. We have denominators of 15, 9, 6, and 18. We have to have the common denominator there, least common denominator. Let's factor. 15 is 3 times 5. 9 is 3 times 3. 6 is 2 times 3. 18 is 2 times 2 times, actually no, 2 times 3 times 3. Come on. Well, if we look at what they all have in common, it's a 3. Remember, it's what they don't have in common that counts. This top one has a 5. All the others need a 5. The second one here has an extra 3. So this needs an extra 3. This needs an extra 3. This one already has it. These have an extra 2. So these top ones, sorry, I'm fighting off a sneeze here. These top ones need extra 2s. So 3 times 5 is 15, times 3 is 45, times 2 is 90. 3 times 3 is 9, times 5 is 45, times 2 is 90. If we multiply all those up, they all multiply up to 90. So 90 is our least common denominator. So that means we're going to multiply this mess by 90. So we're going to do 90 times this first fraction. 90 over 1 times 4x plus 3 over 15. Again, we treat that top like it's in a parentheses. $15 and 90 cross cancel. Both actually divide by 15. 15 divided by 15 is 1. 90 divided by 15 is 6. 6 times 4x is 24x. 6 times 3 is 18. The second fraction here is kind of tricky. We have 90 times this. It'll be 90 over 1. But we've got this negative 1 out here. We treat that as times negative 1 times, we've got the 2x minus 3 over 9. So the first thing I'm going to do is I'm going to combine the 90 over 1 times the negative 1. And I'm going to get negative 90 over 1. We treat the top of that fraction like it's in parentheses yet. Negative 90 and 9 both divide by 9. 9 divided by 9 is 1. Negative 90 divided by 9 is a negative 10. So I now have negative 10 times 2x is negative 20x. I have negative 10 times negative 3 is positive 30. That brings us to the equal sign. Now we still have to keep multiplying by 90 on the other side. So 90 times the 6x plus 4 over 6. So 90 over 1 times the 6x plus 4 over 6. Once again, we treat the top of that fraction like it's in parentheses. 90 and 6 both divide by 6. 6 divided by 6 is 1. 90 divided by 6 is 15. 15 divided by 6x is 90x. 15 times 4 is 60. And at last, we have 90 times x over 18. So 90 over 1 times x over 18. 90 and 18 both divide by 18. 18 divided by 18 is 1. 90 divided by 18 is 5. 5 times x is just 5x. So now that we've done that, we're at the point where we begin to start to simplify this, to solve it. So we combine what we can on each side. On the left, we've got 24x and negative 20x, which makes positive 24 and negative 20 make 4x, positive 4, yes. 18 and 30 make 48. Very good. On the other side, 90x and 5x make 95x. Now we got the plus 60. So we've combined everything we can on either side. Now we have to make sure that the variable's on only one side. We've got variables on both sides. So we'll subtract the smaller one, which is the 4x. That's gone. We subtract 4x on the other side. So we've got 48 equals 91x plus 60. And then we subtract 60. 48 minus 60 is negative 12 equals 91x. And we divide by 91. X equals negative 12 over 91. That's about all we can do with that. What do you think? Happy times? I probably won't do anything quite that bad to you on a test or quiz. Just be aware that it's a possibility. That would be the next step up. So it's possible, depending on what your next course is, it's possible you may see something like that. It's even possible you go one step further and see something like this. So you can see that the x appears only in the denominator of the fractions here. So we've got 6x, 3, and 2x are our denominators. Remember, for our least common denominator, you did the numbers. For 6, 3, and 2, the least common denominator will be 12 would work, but 6 works a little bit smaller. For the variables, remember we take the highest power, which in this case will just be x. So we can multiply this thing. The 12x would have worked, but we're going to do 6x. So here you've got 6x over 1 times 5 over 6x. Well, the 6x's just cancel out. We've got 5. Here you got 6x times 2/3, so 6x over 1 times 2 over 3. 6x times 2 is 12x. 1 times 3 is 3. 12x divided by 3 is just 4x. We have the equal sign, so I put in the equal sign. Then we have 6x times 7 over 2x. So that's 6x over 1 times 7 over 2x. You can cross cancel here. I found most people prefer to just multiply it out and reduce. 6x times 7 is 42x. 1 times 2x is 2x. You divide 42 divided by 2 is 21. X's divide out, so it's just 21. So now we're left with this equation, 5 plus 4x equals 21, that we can solve. What do we do with it? We subtract 5. So 4x equals 16, and then divide by 4. X equals 4. Now again, I won't be quite that mean to you on our test or quiz, but be aware as you move up to the next step, next math course, you might run into stuff like that. There is a new quiz due tomorrow, Tuesday, at 11:59 p.m. And there is new homework due for Wednesday. Wednesday is a review day. On Thursday is our Unit 2 test. So be aware, it's coming. Any questions?